So welcome to 15.8, translations in the coordinate plane. So we're going to be translating, which means move or slide objects in the coordinate plane. All right, so we're going to do a little bit of translating here. So the first one starts at 2, 4. So 2, 4. We have to move 3 spaces to the right. Now when you move 3 spaces to the right, you end up adding 3 to the x coordinate. You'll see this. 1, 2, 3. Right, so we went from 2, 4, and we ended up at 5, 4. We ended up 3 spaces to the right. Second one, we start at negative 3, negative 1, which is right there. And we're going to move negative 3, negative 1. And we're going to move 4 spaces up. And when you go 4 spaces up, you end up adding 4 to the y coordinate. 1, 2, 3, 4. And now we're at negative 3, positive 3. Oh, and we're supposed to call this B. And the first one was A, right? Yes. And the first one was A. And lastly, we start at 7, negative 6 right there. We move 5 spaces to the left. And when you go 5 spaces to the left, you end up subtracting 5. 1, 2, 3, 4, 5 from x. And we ended up at 2. And we're going to move 2 spaces down, 1, 2, which is subtracting 2 from y. So we went from 7, negative 6, and we should now be at 2, negative 8. And we are, and we're going to call that C. And I just show you how to do translations. So this is called said prime. So when you see that, it means we started here. That's the pre-image. And the image where we end up is the prime. So we translated this from A to A prime. So that's what we're going to do first. We're going to translate D 5 spaces to the right. That's a parallelogram. And we're going to move it 5 spaces to the right. And the way you do that is you pick a corner. Any corner is fine. And move it 5 spaces to the right. 1, 2, 3, 4, 5. Pick another corner, move it 5 spaces to the right. 1, 2, 3, 4, 5. And you're going to get a congruent image, the exact same image, just the whole thing 5 spaces to the right. So we're going to move this corner 5 spaces right. 1, 2, 3, 4, 5. Right? Now, there are plenty of shortcuts here because you know you're getting the exact same object over there. And so then we're going to do a little erasing here, and then you're going to write D prime, and we just translated D 5 spaces to the right. Now notice, when you move it 5 spaces to the right, there are not 5 spaces in between, because each point on the parallelogram has been moved 5 spaces. In this case, there were only 3 spaces in between. All right, so let's try another one. So let's try E, and what does it say to do? It says translate E 7 spaces up and label the new one E prime. So we're here, we're going to go 1, 2, 3, 4, 5, 6, 7 spaces up. 1, 2, 3, 4, 5, 6, 7 spaces up. Right, you should get the exact same triangle, a congruent triangle. And we're going to label that one, clean it up, and we're going to call it E prime. We just translated. We can label the translation for each vertex. Right, so let's see that. So 1, 4, here's 1, 4, where did that end up? It got translated to 6, 4. And 3, 4, right there, I should use a different color. 3, 4 got translated to what? 8, 4. And 2, 7 right here got moved over there and now is at 7, 7. And lastly, we have 4, 7 is now over here at 9, 7. So what happened there, right? We moved this 5 spaces to the right. We ended up adding 5 to each of the x coordinates, right? The x coordinate got added 5 in the translation. All right, so this is the one we did from E to E prime, right? We moved each thing. Let's show the first one. So negative 8, negative 6 is right here. That's the first one. Is now at negative 8, positive 1. And so this was moved 7 spaces up. So we're adding y to y coordinate. So this one better be at negative 6, negative 3 better be at negative 6, positive 4. And it is. There it is. Negative 4, negative 6 should now be 7 spaces up at negative 4, positive 1. Translate, that's a trapezoid, FGHJ, 5 units right, so that means we're adding 5 to each of these, and 6 units down, so we're subtracting 6 from each of these. So let's see if we can do it both ways. I'm going to physically move it. I'm going to pick a corner and go 1, 2, 3, 4, 5 units right, and 1, 2, 3, 4, 5, 6 units down. So there's J prime right there. So J was at 4, 4. That's this one here. So and now it looks like it's at 9, negative 2. Did the math work out? Yeah, 4 plus 5 is 9. 4 minus 6, negative 2. Now notice, I don't have to move all 4 corners. I can see that this is 3 units long. So F prime must be there. So F prime was at 1, 4. And now it's at 6, negative 2, right? We added 5 and subtracted 6. Okay, and so we can draw the rest of this. There's the trapezoid. There's G prime and H prime. G was at 2, 1, and now it's here at 7, negative 5. That makes sense. And H prime was at 3, 1, and now is at 8, negative 5. Right, we added 5, we subtracted 6 for the movement. Oops, I need parentheses on the last one for the ordered pair. All right, so what happened from W to W prime? There's more than one right answer, but let's go. We got 1, 2, 3, 4, 5. So we went 5 units right. And then what did we do? 1, 2, 3, 4, 5, 6, 7. 7 units up. Could you have written 7 units up first? Yes. And then 5 units right after? Yes. And so we translated from, right, this was at, what, 3, 2 is now at 8, 9. We went 5 units right and 7 units up. All right, line segment AZ to line segment A prime Z prime. That's how you say that. So what did we do? We went 1, 2, 3 units right. Right, I know I have to start at the one without the primes. Units right. And then we went, now we have to go all the way down to here. Right, so 1, 2, 3, 4, 5, 6, 7, 8, 9 units down. Right, we went from 3 down to negative 6. That's 9 units. Last one, angle B. So you just look at the vertex. That's all you got to look at for an angle. So now we started at B. So we went 1, 2, 3, 4. 4 units left. Right, because we started at 6 and now we're at 2. And then 1, 2, 3, 4, 5. 5 units down. You always end at the prime. The new image is congruent to the pre-image. So what you start with is called the pre-image, right? So when you look in the mirror, you're the pre-image and the reflection is the image, right? You knew that the reflection was called an image, so you had to come before it, and hence you're the pre-image. That's why it's weird like that. All right, so what's the area of KLMN? Well, you just count the boxes inside, or you could multiply 5 times 2, right? It is 10, right? It is 10 square units. It's an area. Now, translate KLMN 4 units left and 7 units up. So I'm going to pick a corner. I'm going to clean it up a little bit. 4 units left. So I'm going to take N and go 1, 2, 3, 4. I'm way out at negative 10 there. And 7 units up. 1, 2, 3, 4, 5, 6, 7. And this thing is 5 long, right? We just said that. So 1, 2, 3, 4, 5, and it's 2 units this way, obviously. And so let's now clean it up a little bit. And so we have n prime and k prime and l prime and m prime. And right, we should have gone 4 units left. -6 minus 4 is -10. Yes, I'm looking at this n here. And then 7 units up, -6. Oh, -1 plus 7, +6. Yes, so I've translated it correctly. What's the area of the other one? Well, it's the same size. And so what we're trying to get at here is that when you translate an object, it's always the exact same size and shape. It doesn't change, and so therefore it is congruent. That means all the angles in here are congruent to all the angles in all the corresponding angles in the other one. All the sides are the same length. The area is the same. The perimeter is the same. It's all congruent, same size and shape. To find the area of ABC, well, the base is 2. And the height is 1, 2, 3, 4, 5. So area for a triangle is 1/2 base times height. So 1/2 2 times 5, or 5 square units. Find the area of A prime, B prime, C prime if the pre-image is translated 5 units to the right. Well, it's going to be the same. It's a trick question, sort of, although I just did one. All right, and we are gonna do the translation 5 units to the right. So we're at -4. We're gonna go over to +1 here. Yeah, so now they can go across. They can be sort of messy on the axis like that. Now there's A prime. You want to label your vertices with your primes, but it's still 5 square units. It's congruent. Translate KLM 4 units left and 7 units up. Determine the new coordinates. All right, so 4 units left. So we're going to subtract 4 from each of these. And 7 units up, we're going to add 7 to all the y's. Let's see. -4 minus 4, -8. -1 plus 7, 6. Let's see if that's right. Okay, so we're going 4 units left. 1, 2, 3, 4. And 7 units up. 1, 2, 3, 4, 5, 6, 7. Did we end up at -8, 6? Yes, we did. So let's do the other ones. L should be -3 minus 4, -7. -6 plus 7, +1. So L should end up at -7, +1 right there. Then that makes sense. And so it's pretty obvious where M is going to end up right there. And I should be, I couldn't draw that straight. I just kept trying to make it better, and I kept making it worse. All right, so now I'm going to clean it up. There's K prime, L prime, M prime, and M is at -9, +1. Are KLM and K prime, L prime, M prime congruent? Yes, they are. Find the area of both triangles. It's 1/2 base times height. The base is 2, and the height is 1, 2, 3, 4, 5. And it's 5 square units again, boy. That's easy. All right, so describe the translation of D to D prime. This is actually part of the standard. So you move this line. How did you move this line? You went from -7 to +3. We translated it 10 units to the right. Because we start with the pre-image, that's the pre-image, the line D, to the image D prime. Good luck with the homework.